Hello, Chem 1. Welcome to the second video of the week. We're determining the relationship between quantities in chemical reactions. The last video focused mostly, if not exclusively, on mole to mole relationships. And yeah, I threw in a little bit of volume to volume connections where there were direct connections using the balanced chemical equation. This one's going to be a little bit different, and it's going to focus a lot on measurable quantities and maybe not direct connections, but maybe a little bit more complicated than that. So let's get going. So the homework for this week is for this particular video is going to be very similar to last week's, where there is a mass to mass conversion sheet on your OneNote homework page. Print it, complete it, scan it, or take a picture of it, and then attach it back to your OneNote homework page, just like last week. I know a couple of you guys had issues with that. This would be a good opportunity to get used to that. Very similar to what is happening with actually the AP. This year's AP, they're having them do the work and then scan and or take a picture of their work and attaching it online. That's where this idea came from. So that's the case here. Now the other thing is you can check your work with Google Classroom to check your answers. You do not have to do that, but I think that's just helpful to see whether or not you were doing it right. As of the taping of this video, I have not put the answers in Google Classroom yet. Hopefully I'll get to that. This is Monday. I'll get to it later this afternoon or this evening, maybe as late as tomorrow before our meeting at 1 o'clock. So anyway, let's go. So from a couple weeks ago, we were focusing, before we did empirical formula, molecular formula last week, we were looking at simple stoichiometric calculations. So if I were to ask you, if I had 183 grams of octane, how many moles is that? You would be expected to use this chart where we looked at relationship between mass and mole and volume, mole and particles, and there were three branches there. Well, in this question, it asks you what is the number of moles in a certain number of mass. So we're going to do this section right here using the molar mass. So what you would do is start with your grams, and then once you take your grams, you would take the appropriate conversion factor. In this case, it's the molar mass of octane. Octane is C8H18, so you would take the molar mass of C8H18 and calculate the number of moles by making sure you set up the dimensional analysis, something you need to get reused to, where grams is on top, grams is on bottom, and they cancel and leave with moles, and I find that I had 1.6 moles of octane. Now you may ask yourself, why did we go back to a couple weeks ago? Well, this whole unit links together very nicely, and today will be a nice blend between what we did 2 weeks ago and what we did earlier today of connecting together moles and moles between compounds as well as measurable quantities. So in the last video, I could have asked you a question, and actually we did, of in a combustion reaction of octane, which is the reaction I just used in our example today, how many moles of oxygen were needed to react with 1.6 moles of octane? And again, this is very much reminiscent of why I chose the reaction I did for the initial reaction, is to show you there's this connection that goes between the pieces. So in the last question, we came up with that 183 grams of octane was actually 1.60 moles. Well, now I want to look at another compound. I want to look at oxygen. So if I want to know if for the 1.6 moles of octane, that's a C8H18, how many moles of oxygen I need, I'm going to make the connections like we did yesterday or earlier today, where we went between volume to volume, mole to mole, or particle to particle using the BCE, or the balanced chemical equation. So what you would do is start with your number of moles of octane, use your molar ratio of 2 to 25, and we found out yesterday or earlier video that we had 20 moles of oxygen would be needed. And that was yesterday, or again, the last video where we focused on the mole to mole ratio. Also slightly reminiscent, slightly connected to what we're doing and what we did a couple weeks ago, we can go from moles to volume. Okay, so just let's take that 20 moles of oxygen and say if we had 20 moles of oxygen, what would that volume be at STP? Okay, what would that volume be at STP? Well, we're going to go back to this table where we go from moles to volume using the 22.4 liters per mole. And we're going to start with our 20 moles, do our 22.4 liters per mole, do our math, and find out we could get 448 liters of oxygen. Now, you may ask, why did we just do 3 different problems all over the place that seem to be, maybe you saw they were slightly connected? Well, they are. And they're connected based on what we're going to do today. And we're going to focus on looking at bringing all those pieces together into one problem. I started by asking you how many moles 183 grams of octane was. And we ended up asking what's the volume of oxygen, and they were all linked together. We took this table and this table, and essentially what you're going to do is link the two together. So if we take this table that we had and we link up the volumes and the moles, what we're going to be looking at is substances that are given, information about substances that are given, information about given quantities of volume or mass or moles or particles, and we're going to find out volume and moles and particles and mass of an asked for quantity. We're going to connect them together like we did on the earlier video through the balanced chemical equation, and then essentially we have a mirror image of the other side. So we can go from one side of the equation to the other. The left-hand side will represent measurable quantities that we would have of a given material. And then since this is stoichiometry and you're talking about multiple types of products, multiple types of materials, the asked for side is going to be the other substance you're going to be asked about. Let's just see how this works. So in our example, we said, what's the volume of oxygen gas that is made at STP when you react 183 grams of octane? So we took the octane, we changed it to moles. We took the moles, we changed it to moles of oxygen. We took the moles of oxygen and changed it to liters. And voila, we got 448 liters of oxygen. Now, that may have been a little quick. Okay, that may have been a little bit too quick. So what I want to do is I want to show you a plan. And this plan, actually, there's a story that goes along behind it. It's called Explicit Method. Okay, and just to make sure that I'm crystal clear, Explicit Method does require you to do a little bit more work. And actually what you're going to be doing is putting on paper what will, in time, be going on very smoothly in your head. Okay, but I want you to initially put it down on paper to get used to not trying to dive right into the deep end of the pool, but to try to take little steps and learn little steps and grab little pieces and then ultimately bring everything together. The short story is this was my master's thesis, was trying to determine whether or not this was more effective. And the short version of the story is there was a 12% increase in the scores of people who use Explicit Method versus those who were not taught the process of Explicit Method. So let me teach you how to do Explicit Method. And I'm going to ask you for today's homework, the one that's associated with this PowerPoint, to do all your work using Explicit Method. And actually the stuff that's online gives you space for the parts of Explicit Method. So what is Explicit Method? Well, you're going to take a problem, much looks like this one. Look what we have here. Determine the mass of lithium hydroxide produced when you take 1.38 grams of lithium nitride and react it with water. And just to help you out with balancing equation, they said ammonia is the other product. So I need to use what's called Explicit Method. Again, it's the thinking process. It's explicitly and verbally writing down everything that should be going on in your head. So the steps are, first, you write down what's given to you. You write down everything that's given to you. And I think anytime you're doing problem solving, the first thing that's really, really important is to figure out what information do you have. And then secondly, what are they asking me to solve for? That usually labeled as the unknown or the asked for. Then to make life easy or to make sure that you're on the right page, you want to have a plan. And then you're going to recall facts that are important to make sure that that plan can actually come to fruition. And then finally, you can solve it. Now, my Chem 2 kids and my AP kids jump right to the solve section. And I totally understand that because they've been doing for 2 years, 1 year or 2 years, they've been doing stoichiometry, and it's become pretty common for them. But I do know beyond a shadow of a doubt that this process does require some planning, and we're going to go ahead and ask you for these earlier steps until we get the hang of this, to write out your plan. It helps. I can't say it enough. It absolutely positively helps. So let's walk through this. Here's my example. Okay, so first step of the explicit method is the given. I write down what's given to me. The only thing that's given to me is that I am given that I'm starting off with 0.38 grams of lithium nitride. And I can write down what the formula for lithium nitride is to make sure that life is easy for me. Then I read through the problem and I say, well, what was asked for? Well, what they asked me to solve for was the mass of lithium hydroxide. What's my mass of lithium hydroxide produced? So I know that's what I'm shooting for. I know that I have done the problem correctly if I start with the grams of lithium nitride and I end up with a mass of lithium hydroxide. So next step is to come up with a plan. Now, to come up with a plan, I need to use the mole diagram that we had on the previous slide. So let me look at this. Now let's walk through this. This is probably one of the more important pieces to make sure that you do this right and to have a plan. So if I look at this table, I am given that I have 0.38 grams of lithium nitride. That's right there. That's my mass. The question asks for the mass of lithium hydroxide. So again, it's asking for mass, and that's right there. So what I need to do is my plan will consist of going from the mass on the left to the mass on the right in a series of steps that allows me to go straight down Main Street in this case. So my plan would be to go from mass of lithium nitride to moles of lithium nitride to moles of lithium hydroxide to mass of lithium hydroxide. That's my plan. I'm taking the table that I have that you should be used to using if you haven't printed it out. Actually, the last slide on this PowerPoint is a clean version of this particular table. You can always print that out to have it lay next to you when you're trying to work on these problems. But the very, very last page of this PowerPoint is this table. Without any of the colors, it's all cleaned up so it's easier to follow, and you can color however you want to. So that's my plan. So there's my plan. I have mass of lithium nitride to go to moles of lithium nitride, moles of lithium nitride to go to moles of lithium hydroxide, moles of lithium hydroxide to go to mass. And what I have are a series of 1, 2, 3 separate steps that if I do them individually in order, I focus on each one, it makes life a lot easier. So let's think about it. This first step, A, what do I need to go from mass of lithium nitride to moles of lithium nitride? Well, what I need is the molar mass of lithium nitride. That is my conversion factor that goes between lithium nitride mass and the lithium nitride moles. So as my recall step, that's what this step is here, the recall, I'm going to go ahead and I'm going to write down what is my molar mass. I'm going to look it up on the periodic table. I'm going to add the numbers together. I'm going to write that down. Step A requires this information. Then I look at step B. What do I need for step B? Well, for step B, I need the molar ratio from the balanced chemical equation. So in order to do that, I need a balanced chemical equation. There it is. You'd have to write, sometimes you'll have to write the equation, sometimes it'll be given to you, but you need a balanced chemical equation. And the molar ratio I'm looking at is the relationship between lithium nitride, Li3N, and LiOH. Well, I can see it's a 3-to-1 ratio. So my ratio is 1 mole of lithium nitride for every 3 moles of lithium hydroxide. And then finally, what do I need for step C? Step C, again, I'm going from moles to mass. I'm going between mass and moles and mass. I need a molar mass, this time for the lithium hydroxide. So the lithium hydroxide's molar mass is that value. So now what I have is I have my 3 quote-unquote roads that allow me to go from mass to mole, then mole to mole, then mole to mass. I have my 3 conversion factors that are needed. Now the last thing you need to do is put it all together. Is to literally take those 3 recall steps, those 3 conversion factors, and lay them out in such a way to go through the dimensional analysis. So here's what I have. Always, always, always start with the given. There's my given. Then I'm going to look at step A. I'm going to look at step A, and I'm going to, for every step along the way, I'm going to ask myself, in order to use step A, do I leave it alone or do I flip it? In this case, in order to put the grams on the bottom, I need to flip it. So I'm going to write it upside down. For step B, I might ask myself, do I leave it alone or flip it? You're just going to go across A, then B, then C, grab each one and ask yourself, leave it alone or flip it. Well, for step B in this situation, since lithium nitride is on the top here, I want lithium nitride to be in the bottom. So the way that I wrote this one, I need to flip it. So I'm going to put the lithium nitride on the bottom. And then finally, I look at my last reaction. Now I have moles of lithium hydroxide on top. I have moles of lithium hydroxide in the bottom here. So for the last conversion factor, I'm just going to write it as is. And then I'm going to do the math. I'm going to put in my calculator, 0.38. Now, anytime something is in the denominator, we've seen this before, anytime something's in the denominator, you divide by it. So I'm going to divide by 34.830. Anytime something's in the top, I'm going to multiply by, so times 3 divided by 1, times 23.948, and I get 0.78 grams of lithium hydroxide. I'm going to say with the calculator piece, when punching this stuff into the calculator, anything that's in the top, I'm going to hit times in front of it, multiply by that number. Anytime something's in the denominator, I'm going to hit divided by and divide by that number. And I'm just going to walk from left to right. I know some of you guys like to take all your top numbers, multiply them together, take all your bottom numbers, multiply them together, and that'll work fine, but that's a lot of writing numbers down, a lot of making mistakes, and a lot of transcription errors. All you need to do is walk from one side of the equation to the other. That time, anytime something's at the top, multiply, anything is at the bottom, divide by, and then get an answer to the right number of sig figs. So the question is, how many grams of lithium hydroxide can be produced if I start with 0.38 grams of lithium nitride? The answer is 0.78 grams of lithium hydroxide. Okay, so this is a typical mass to mass equation, very, very much like the ones that you're asked to do for your homework today. So let's see whether you can do one on your own. Determine the mass of carbon dioxide produced when 0.85 grams of butane reacts with oxygen. This is that combustion reaction. Remember that in a combustion reaction, the other product is water. Go ahead and pause the video, try this on your own, and when you come back, I'm going to go ahead and click forward and show you the answer as to what you should have done. So try this one completely on your own. Don't fool yourself into thinking you can just watch the video and see how to do it and you're fine. Take a moment. It'll probably take you a solid, I'd say 5 to 10 minutes to do this. Go ahead and check your answer in a second. So pause the video. Okay, so hopefully you did heed my warning and suggestion. Try it on your own. Let's see how you did. Here's the answer. If you wanted to figure out how many grams of carbon dioxide that we produce from 0.85 grams of butane, this is the process you do, and you should have gotten 2.6 grams of lithium hydroxide produced. How did you do? Well, hopefully you did pretty well, because your homework for this chapter or for this particular PowerPoint looks a lot like this. You're going to set up a explicit method, spot for the given, spot for the asked for, spot for your plan, recall steps available to you, and then you're going to show, solve, and make sure you round to the appropriate number of sig figs. Here's that table that I told you was at the end of the video so that you can print out. So what's next? We're going to spend one more time, the beginning part of next week, we're going to look at other combinations. Maybe we're going to move around this thing. Besides going down Main Street, we'll make some offshoots a little bit along the way. So for this week's practice, make sure that you can do mass to mass. Hopefully everybody is being healthy, safe, and practicing your social distancing. I will see you on the next video, or I will see you this week on Tuesday and Thursday in our teams meeting. Have a great day. Toodles.